Hi everyone, we should be live now. My name is Yuri Kuzemko and today we are doing our second live coding session where we going to make a cost-effective deployment to the DigitalOcean cloud using Kubernetes. So the goal of this live coding session is to show the experience about how we creating the systems and different kind of deployment infrastructures under different conditions. And it involves really doing a lot of experiments, a lot of investigations, a lot of trying things out, and yeah, checking a lot of technology stuff and deployment stuff. So our goal is today actually to have the reliable, flexible deployment infrastructure that will allow us really to um, manage a lot of different deployment configurations, uh, have this deployment reliable. So we won't we won't care like about different kind of outages or everything. So it's gonna be like reliable and also have the deployment costly optimized. So it's not kind of like we want to build some multiple $100 a month cluster, but we just want to launch a simple uh, deployment infrastructure that will cost us around $12 a month, because this is how the DigitalOcean plans offering us to start with. So yeah, and if you see, we have the DigitalOcean page open here, and if we see the pricing, okay, so they can tell us the Kubernetes starts from $12 a month. This is the cost of the monthly cost of one node, which is really has low resources, but for low scale application like we're doing right now, is going to be pretty sufficient. Furthermore, the benefit from DigitalOcean that it supports auto scaling. So whenever we experience some bigger loads and our node of this $12 a month node won't handle this load, it means that the DigitalOcean automatically add a few more nodes to satisfy this traffic demand, to compute all these requests, and then after this traffic will go away, the DigitalOcean will downscale it and all of these. So of course you will pay additionally for the other nodes, but you pay, I guess, for hourly basis. So uh, let's say if you launch 3 nodes to running continuously, so you're gonna pay $36 a month, right? But if let's say you have 2 times a week where your traffic goes up a bit and you need additional nodes for that 2 times a week 1 hour intervals, so you will pay, I guess, no more than $13 to $15. And this is the benefit of Kubernetes, and this is the benefit of DigitalOcean, because it's really developer friendly, and yeah, it's on the low scale for experimenting, for doing stuff like that. It's really cost efficient. Uh, okay, so I'll go ahead and describe you how our infrastructure looks like. So we're doing the Kubernetes deployment, but also we using Helm to package our Kubernetes deployment into the Helm charts. And this is because it's much easier to configure as the deployment, so we can have flexible template language where we can have a centralized configuration and then populate it uh, across our deployments whenever we need to, and we can run the same deployment code for multiple environments, and we have it configured, so we just change the configuration file in one place and everything works smoothly. But also if it comes to Helm file itself, for instance, if you have multiple different deployments with the Helm file, every time you want to change something, you need to run the Helm command like for each of the deployments. It means like you have NAN, Qualcomm website deployments like we have. You need to execute the 3 commands every time to apply the changes to our infrastructure. And usually people writing their own bash scripts to make the Helm deployment that contains a lot of different Helm file executions. But hopefully today we have a great solution that called Helm file. So this is not Helm, this is kind of another third-party solution that really provides the ability to create an abstraction on top of your Helm charts, and you don't need to manually add repositories. All you just do, you create a Helm file YAML where you're specifying your repositories, where you can specify your releases for different repositories, and you can specify the values, custom values for each of the release. You can load your values file based on the environments, and all you can do, you can run the deployment by using just one command, helm file apply, and you specifying the environment in front of which you're running this. So this is really nice tool because it's really bring you ability to have the complex infrastructure set up in YAML files. So it's explicit, it's clear, it's configurable. Yeah, and I just like using it. It's really simple. You will make change, run the command, and this change got populated. So yeah, we're using these for our deployments. So in terms of the services we're going to be deploying, today I'm going to deploy my custom website to the Kubernetes, but of course deploying the simple static website to Kubernetes has no reason. But next to the website, I have a few more deployments. I want to deploy the N8N platform. If you're not familiar with that, you can check their website, n8n.io. It's really nice, flexible platform where you can build your custom automations almost without coding. Like maybe you can have a bit of coding, but yeah, you don't need to deploy your custom scripts every time if you want to create some integrations, some webhook handlers, some automations. You can do pretty much limitless stuff with that, like different kind of integrations. For instance, I have integrations of my bank account to my financial tracker software because natively it doesn't support this integration, so I created it manually, really simply with a platform, and a whole bunch of integrations like that, different kind of marketing automations. So yeah, that's why I love this platform. So it's pretty much, I was explaining about this in my previous live stream, but I'll go ahead and duplicate it. So this platform pretty much the same as Zapier, but Zapier is hosted platform. It's expensive on the larger scales, and the Zapier license itself will cost you more than our complete deployment price. And also, Zapier is pretty limited in terms of customizations, because as far as N8N open source, you can extend their code base, configure to whatever you need to, and that's why I love it. So yeah, we're gonna be deploying this. And another thing I wanted to try it out, I've just never deployed only locally, is the calendar scheduling software called Calcom. So this is pretty much, I guess, this is an open source alternative for Calendly. And yeah, I'm just, I need to have multiple event types in my Calendly, but I don't have a lot of bookings in my calendar. Like I might have a few bookings a week, or even sometimes a few bookings a month, but I don't want to buy a license of the Calendly to just have 3 types of calendars. That's why I've decided that Calcom looks pretty well. And I'm not sure about, by the way, their licensing, because they have the free version of one event type, and then they have the paid version of unlimited event time. And I just can't understand why the self-hosted version would be premium or free. So that's why I decided to just deploy it, try it out, and see. So this is, I'll be deploying it. Okay, and so we're gonna be building, already built, by the way, the N8N Helm chart, and I'll build the Calendly Helm chart as well. And I built the website Helm chart with you today as well. The other thing about our cost efficiency is that in our Kubernetes cluster we're using custom Nginx load balancer, because if you want to use external load balancer, first of all, for my opinion, Nginx is much more flexible and configurable. But even if you want to benefit of having managed load balancer, like DigitalOcean load balancer, you should pay for it around $10 a month additionally. And in some highly loaded use cases, it might make sense, but for us right now, as we going low scale for just having cost efficient, so we have our custom engine load balancer set up so far. And the beauty of DigitalOcean, what I like about it, is that you just set up your custom load balancer. DigitalOcean automatically assigns the IP address for it. Uh, when if you try, for instance, it's the same Google Clouds. Google Clouds will require you to manually create a static IP address and pass it to your configuration, so it's much more complex. The other thing good, because you can have pretty much the same deployment in Google Cloud, right? So Google Cloud charges you a bit more for the nodes, for the VM instances, so but not like I guess the same capacity node that we have in DigitalOcean will cost you in Google Cloud about like 18, so slightly more expensive. But the biggest downside of Google Cloud for our low scale deployment would be that Google Cloud will just charge you $70 a month, 70, right? Not 17, but $70 a month, around 70, for just having your cluster running. So, and when DigitalOcean doesn't charge you for a cluster, it only charges you for the nodes. For that reason, I think if we're talking about some self-hosted stuff, this is the best ocean, because you're pretty limitless with what you can do with Kubernetes, and DigitalOcean offers you a flexible plan to pay for the no. So for me, it's even more cost effective than running just your VM without any Kubernetes. And having it in Kubernetes also adds you another reliability. Um, so yeah, that's it. Also about our ECR storage. So by default, if you're running your cluster somewhere in GCP using the GCP artifact storage, if you run your cluster in Amazon using the ECR, DigitalOcean offer their own registry, but I'm still using ECR. Why? Because the pricing plan for DigitalOcean registry is slightly different. So on ECR you have just 10 cents per gigabyte per month pricing, which is the same for the GCP. Then for DigitalOcean, they offer you the free hosting for up to 500 megabytes and one container registry repository. But if you want to have multiple repositories and more gigabytes, they have just static flat fee of, I guess, 10 to 15 bucks. And yeah, I just, yeah, you see here, so starting price, but then I guess there is another price of, okay, $5 for five repositories, 5 gig storage. So the ECR will be much more cost effective because they charging you per really per uh, gigs. And why the pricing per gig, so 10 cents per gig per month, is the same for GCP and ECR, but in ECR we have something called lifecycle policy, where you can set up your rules how to prune all old images, right? When, for instance, in GCP, if you have like a lot of pushes to your container register, let's say 10 pushes, 1 gigabyte each, so your ECR will store, let's say, if it's reusing layering in Docker, it will store 5 to 6 gigs. You need to pay for 5 to 6 gigs. So in what I do usually, I don't need to store the old version of my deployments. Usually I'm storing only the current and the previous, so 2 versions. You can set up like lifecycle policy, so ECR will automatically delete the older versions of your repository, and thus you will be even much more cost effective. So yeah, and here they offering 5 gigs for $5 with 5 repos. So you can have pretty much the same in your ECR for 50 cents, so 10 times cheaper. But the downside of it, that it requires some kind of hassle, because you need to authenticate your DigitalOcean Kubernetes cluster in front of ECR. But hopefully I already managed to set up the solution for it. Right now I have it in my deployment code, but I'm going to probably create a Helm chart for it so I can publish it in open source and people can reuse it. So yeah, this is the brief introduction of my previous research. So right now we can just go ahead and get started, so I can show you how my configuration looks like and everything. So I'll go ahead to my Visual Studio Code to show you everything. So here right now we have a few things: Cert Manager, NAN templates. I'm just storing. It's not deployment related, so don't mention it. I'm just storing some templates I'm exporting from here. Then the secrets and the Helm. Okay, I didn't mention Cert Manager yet. So usually if you're using external load balancers like DigitalOcean or whatever, they're offering you to manage your TLS certificates, but as we are not using external load balancers, so we want to manage TLS certificates by ourselves, and I wanted this management to be automated, so that's why I'm using the Cert Manager, which is the Helm chart that helps us to manage our Let's Encrypt certificates. Let's Encrypt offers us free TLS certificate for 90 days, and this Helm chart of Cert Manager will help us automatically renew it every 90 days. So we just set up it once and have it effortlessly manage certificates for free, really, by just a few initial adjustments. So yeah, this is, as I explained, really lean way to deploy a low scale application. But even if you go in higher scale, I think that it'd still be much cheaper than running it on different cloud providers. Of course, as far as I know, the limit of the uh, DigitalOcean, it allows you only to have around 500 nodes in cluster, when Google Cloud Platform allows you to have about 10,000, something like that. So the difference is huge, but so we are talking about the project of that level that have 10,000 nodes. I think that's we are not doing such lean stuff on those projects. There we're thinking about more how to better handle the complexity of this traffic and everything. Yeah, so that's how we're doing it. And here is the Helm file configuration there. I'll explain. So yeah, we just loading the values from our secrets folder, and they are structured in the same YAML. I won't show you these values because it contains some sensitive information, but yeah, they just store the data in the YAML file, and then we can just get the data by keys. We have the object, whatever we want. So we using this environment. By the way, this I just didn't figure out what the difference between using just the value versus environment values. I think we can go ahead and just use the values because yeah, I guess as far as I said, I don't know what's the difference. Okay, yeah, so we're using the repositories for our Bitnami, using Postgres, then the engines, and yeah, and also I'll explain about this one in a second. We have releases, so we have the NAN release, and as I explained in previous video, this is my custom NAN Helm chart. I'm going to publish it open source. It's pretty effective because it's designed to scale well on even on the higher load. Yeah, but as far as I mentioned, that we are not expecting high load. Still, this deployment will help you to reach some more reliability of your NAN platform. And yeah, we have the cert issue here. So our cert issue, this is the another deployment that is responsible for managing our certificate. Okay, so right now, what do we need to improve? As I mentioned, we need to add a few more services like website and call.com. Also, we need to set up properly the cert manager, because right now it's not set up. Yes, and the other thing we have right now is we have a solution, as I mentioned previously, to authenticate our Kubernetes to be able to pull the images from the ECR. And usually, if you're using the CLI to pull images from ECR, you're running the Docker authenticate command that returns you some kind of a token that you supply to your Docker logging command. But this token is only valid for, actually the Docker login, yeah, it's only valid for 12 hours. So it means after 12 hours your deployment credentials are invalid, your registry credentials are invalid, and we need to renew them. And I found somewhere in the internet let me show you. I have it somewhere here. We have, okay, values, I guess. So we have the cron job for ECR secrets. Yeah, and I just want to show you because I forgot the name. Okay, yeah, we have this Docker image I found on the internet somewhere, pushed to the open source, and it really helps us to. So what this image does, it just you specify your secret name of your ECR credentials. Yeah, the namespace you have the secret in. You're specifying your AWS region and AWS credentials. And what it's doing is just this job is just authenticates towards ECR and put the authentication secret to this secret file, and you can adjust here your cron job, like for the which period of time you want to execute it. I've set up every 6 hours, so we have every 12 hour we have kind of like refresh, but I'm doing every 6 to have it more reliable. So what I want to do, I want to move these deployment to the separate Helm chart so I can populate it to any namespace, right? So because the challenge is that I wanted to have it centralized. I wanted to have a centralized job that updates the secrets in one place that could be reused by all the deployments. But as I have deployments in different namespaces, and by the Kubernetes native, secrets can't be accessed outside of the namespace. So it means that we need to have this cron job deployment for every namespace, right? We have NAN, we will have website, we will have call.com. So that's why I have I was thinking about moving it to a separate Helm chart, and after we have it in separate Helm chart, we can just create multiple releases of this one Helm chart here in our releases in multiple namespaces. So we're just adding another release to the NAN namespace with the Helm chart of, let's say, ECR secrets, right? So I wanted to do it that way. And the other thing, this is the one thing, the other thing is right now we have our Nginx load balancer located in the NAN namespace, so we are loading it as a dependency of the NAN shard, but really our load balancer would be centralized across all our deployments. So I just want to move the load balancer to a separate namespace, so then it will be able to handle all the traffic from to our cluster and balance it across different ingresses, different namespaces, right? Different services. So this is the two things we want to do today to improve. And the third thing would be right now our cert manager deployment didn't succeed. So we need to investigate why it didn't succeed and fix it. And really, I just wanted to explain on these Helm files object of this YAML. So the Helm file, as I mentioned, is an abstraction on top of the Helm. So you can have, instead of running dozens of Helm commands, you have just a Helm specification here, your YAML specification here, which will do it for you. But Helm files can be related to multiple. So for instance, you have one deployment of NAN and Qualcomm, and it's configurable Helm file, but also you want to have 3 deployments like this to your top level infrastructure, right? So instead of creating a new Helm file, you can just reuse existing Helm files and have kind of like nested Helm file system. You got it, right? So we're using that, but using that for different reasons. So how the cert manager works, actually, you're just applying the Helm chart of the cert manager, and after that you need to create your own cluster issuer. So this is the custom resource that defined, custom Kubernetes resource that defined by cert manager chart, right? And the problem is that when Helm file evaluates our charts, we can specify the order by which every chart will be evaluated. So what we need to do, we need to apply the cert manager chart first, right? Before actually we have Helm file here, we have the cert manager chart. We need to apply it first. We need it to be applied first because it creates CRDs, custom resource definitions, and only after that we can apply the cluster issue. Because if we won't doing it that way, our cluster issue deployment will fail because it will say unknown resource, right? And how I wanted to prioritize it, so somewhere on the Helm file GitHub issue mentioned that you can locate your cert manager deployment as a separate Helm file, and thus it will be evaluated before all the other releases, right? So what we do, we just created a separate Helm file which is not related to this Helm chart at all, just a separate Helm file. And what it does is just, registers the repository for the cert manager and make a cert manager release in a separate namespace, and also it indicates that we should create CRDs. And then we're specifying this Helm chart here, so when you start executing Helm file, it go ahead and evaluates those Helm charts first. Once it evaluated this Helm chart, he goes and starting evaluating all of these. And you see in the last step we have cert issue, which just evaluates our cert issue template and chart, sorry, and our cert issue chart just has one template, which is the cluster issue. So at the end, after everything was evaluated, after we have our ingress created, our engines created, the cert manager, we applying this resource. So now the cert manager can start issuing the certificates, TLS certificates for our ingresses, for our load balancer. Yeah, and for some reason, I guess the reason was because my invalid configuration. This stuff didn't work here. It worked for me in other. Actually, yesterday I was showing the live stream to deploying to GCP, and it worked well there. There were some issues, but we fixed them. But it didn't work here, so we're gonna fix it today as well. All right. So what I want to do now, right now, I want to go ahead and move the engines to be centralized deployment, because right now it's nested into the NAN, and I don't like it because the Nginx load balancer itself, it's not the kind of thing that's only related to NAN. It's a general thing that should have a separate release. So to do that, what we will do, we will go ahead here to short YAML, and we need to add new repository to our Helm file. Right, so okay, we already have this repository, ingress engines, thus we don't need to add it. All we need to do, we need to add new release. Okay, so I'll go ahead and create new release by just specifying this name. Let's call Nginx load balancer. Then namespace, we're gonna create new namespace called Nginx, right? Then we're going to specify, like here, create namespace true. And for the chart, we just specify a name of the chart like we have in our dependencies in NAM here, and I guess this should be specified that way. Let me recheck how we're doing it here so I won't make a mistake. Okay. Yeah, so let's try to do it that way and see. So we have chart ingress Nginx, which is from this repository that we already included here. Okay, yeah, we specify the atomic true. So atomic true settings mean that if some kind of service deployment fails in this release, in this chart, then we just rolling back all the chart deployment, all the release, right? So we don't want to store some kind of half deployed chart, right? Because we don't need chart like this. It doesn't work. And then we need to specify values here to this deployment. I already have this set up. So let me see. Okay, it is located in values in file nan. We have ingress engines, and we have all of these set up that are created. I won't be explaining this, honestly. I just copy pasted them, so I didn't discover all these parameters yet, but I guess we will do another stream, or I'll just record another video for you explaining how to properly set up the Nginx load balancer. But right now I just want to have it set up so it works, and we need those values moved from here to our Helm file. So I'll go ahead and create the, after atomic, I just specify values, and the values we have it array, and we can specify multiple types of values. We can specify even the just a string that will be, let's say, the path to our values file, like these, right? Just an example. But we also can specify a YAML structure with our values like these, and we can have it like next to each other. So the first array would be the path, the second array would be the YAML, and yeah, they will work together well. Okay, so I don't like how it right now. Okay, now it's better. So we have the ingress enabled true. We have a controller. So we have all of these. I think it's enough for us right now. Okay, perfect. So if you're deploying, if I've also mentioned previously, if you're deploying to GCP, so we need to go ahead, create a static IP, and also specify here deployment, service, load balancer IP. But hopefully with DigitalOcean, you won't need to do this, because it will assign the IP to your load balancer. Of course, you can reserve a static address. So you can have a static if you're changing your load balancer or deleting it and want to persist your IP, so you don't need to change your DNS records all the time. You can reserve the static, but I don't want to do it right now. I just want to have it be done effortlessly, right? I'm lazy a bit. All right, so we have the Nginx deployment here. I'll go ahead and remove the dependency of the NAN to Nginx, because we don't want to have it there. Okay, and I remove this configuration here as well, because we already moved it to our Helm file. Let's see whether we have something related. No, we don't. Yeah, that's perfect. All right, so now we have the chart log file, and we need to remove it as well, because whenever we're changing some dependency, our chart log needs to be re-evaluated. So I'll just move it to trash, and whenever we run Helm file, apply it to be create again. Yeah, and so I guess that's all. I just want to make sure that our config is okay, it's proper, right? So everything looks smooth. So let's try it out. Let's then go to our terminal and deploy these Nginx right now. Let me go to my DigitalOcean account so I can keep a look on it from there as well. All right, so I need to change my kubectl context. Sorry, use context. Okay, I've switched the context. Let's see. Yeah, now I have switched the context. Let's verify it. kubectl get pods namespace NAM. Right, now we can clearly see that our pods are up and running. Okay, perfect. So let's go ahead and deploy this version right now. So I'm applying the Helm file production. This is the command how we're making this deployment. So instead of running a whole bunch of helm file apply commands and helm and repositories, we just run helm file specifying the environment production. Also, I'm specifying the debug flag because I want to see explicitly what's going on right now is my deployment, and clicking apply. So here our deployment is running. In the meanwhile, I'll go ahead to my DigitalOcean space and see my Kubernetes cluster that is running well. All right. So we can click the resources here. Okay, you can see that this load balancer created by me, so it's not the, and we have 2 PVC volumes. Let's observe it, what it's doing. So it's making a deployment here. Okay, we got some error. Yeah, let's see. So they don't like the name of our engines template. Okay, let's get to the docs and see how we should properly specify the name, because I am just not remember it. So we have the repository Ingress engines. We need to search it like this. Let's find out Ingress engines. We have 2 different Kubernetes, right? We need to use the from Kubernetes. Okay, cool. We need to specify the release name like this. You see, that was my mistake here. Instead of having it just like this, I need to specify like this. Okay, dope. Let's try it out one more time. Boom. So deployment is going well. We have some error. Okay, we still have some error. Ingress class engines in namespace exists and cannot be imported into current release. Invalid. Okay, they already have some kind of an engines namespace for this. Gotcha. Okay, they just I guess this the issue is that our current load balancers are conflicting. So the old one located in the NAN namespace and the new one in the engines namespace are conflicting. So what I can do, I can just remove the current release, comment it out, and let this deployment to remove the old. So as we removed it from dependencies, we should run helm file apply again, and it should remove the previous engines deployment, and then after that we will uncomment it, run helm file apply again to apply the new deployment. So let's try it out to see if it works that way. Okay, dope. I guess it should be removed. Let's get our ports in NAN space and see. No, okay, yeah, it's terminating, so it has been removed. Yeah, now it's been removed. That's perfect. Let's then uncomment it and try to deploy it one more time. Okay, and I guess right now our issue with cert manager has been fixed. So I guess our uh, cert manager chart was deployed. So we can check it, by the way, in the Perl terminal. So let's try it out once while we have this deployment. Let's see the namespaces. We have the cert manager namespace here, as you see. Okay, yeah, we have the cert manager up and running, so it works well. Yeah, and our load balancers seem to be deploying well, so it still doesn't have the IP address, but the DigitalOcean working to give us IP address, so it will hang in that state for a while, and then return back to normal. So let's wait. We can also run kubectl get ingress namespace nan and see. Yeah, you see we have two ingresses right now, and none of these have the IP address. So let's wait until the load balancer will give us an IP address. And as far as this IP address will be new, I need to go ahead to my DNS provider and change my A record for the domain that is serving my NAN. And by the way, in the meanwhile, you see that we have the NAN ingress, and this is SM ECMA HTTP solver. So this ingress is created by Cert Manager, and it's designed to solve the ACME challenge that is about validating our domain ownership. So we can so the Let's Encrypt can validate our TLS certificates. Yeah, so it's still working on it. We need to wait for some period of time. Yeah, let's just wait. It should be solved in a while. In the meantime, I'll try to set up my DNS in the background. Okay, I see that we got an IP address for our, not yet, but okay, our ingresses still doesn't have the IP addresses, but the load balancer should get. I don't know why our ingresses don't have yet. Maybe it requires some time for them to understand these. So let's go then to the DigitalOcean and check our ingress. I guess it should show the IP address for us. So sorry, I mean load balancer. Okay, so I guess we have this API. We have this one, health thing. Okay, this is should be our new IP address, I guess. Let's check our ingress. Yeah, our ingress now obtained IP address. Here how it looks like. That's perfect. So I'll go ahead and change it to my DNS. I won't be sharing it. I won't be sharing my gosh, my DNS provider with the security purposes. All right, perfect. So I just did it on the background, um, and our let's see our ingresses here. Yes, and as you see that this ingress disappeared, so it means our certificate has been issued. So let's go ahead to this domain and take a look on our certificates. I'll do it with HTTPS. All right, so okay, we have the issue with too many redirects. I don't know what causing it. Okay, let's try to do it without the certificate. Okay, it's still erroring. I don't know what's causing it. Right, because what I did, I'll try to turn off the proxy on top of. Let's try it one more time. It still doesn't work. Let's see the logs of our load balancer. So we have the engines. Okay, I just close this second because I don't need to keep ctl logs namespace engines. All right, what do we have here? A whole bunch of logs. So certificate not found, but that was fixed, I guess, because right now you can, by the way, kubectl get certificate namespace NAM and check it. So yeah, we have an issued certificate here. Let's encrypt. This is perfect, but for some reason we still have the redirects issue on our domain. That okay, let's wait for a while. Maybe it takes some time for the DNS provider to change the to apply the domain the A record change. It might take up to 5 minutes, I guess. We can do the DNS lookup in the meanwhile. So it will help us understand to which IP address our domain is pointing to. Let's remove all of these and then go ahead. So it can just okay. All right, so what can we see? We have yeah, we can see our new AP address. So maybe right now it has been resolved now, but too many redirects. Try cleaning your cookies. Okay, let's try that in incognito. I'll go ahead and open incognito. We have the same in incognito. Too many redirects, and I can't guess why it's happening. I'll check the ports in the NAM namespace just in case something crashing. No, everything seemed to be working well. So the issue is not the NAM, but we have different kind of like weird. So we have this IP address attached to our. Let's compare it to our DNS lookup tool. That might be cache issue actually. Usually it happens because of the cache when you're doing things like that. Let's Google it. Let's find some clues why it's happening. Okay, this shouldn't be the cookies issue because I've just cleaned my but let's try to clean the cookies maybe, because I've tried to eat from incognito. Incognito shouldn't store cookies. Okay, if we are not talking about WordPress, we can set up the engine slot balancer to many redirects. Let's search it like this. Also, I'll Google this one, because if you see here we have the 308 status code. It means that request resource has been permanently moved to another URI. Okay, I see that we have invalid default SSL certificate name. Maybe that is the issue. So I'll try to reapply this deployment one more time, but this is a weird issue. I've never experienced something like that. Also try from my other device in the meanwhile. Maybe it will show something different. Okay, it works on my other device. It works. So the problem was in cache, in local cache. I just tried it from iPad and it worked. So we even don't need to doing all the crap I'm doing right now. But never mind. Let's fix it because there was a typo there. So I think it won't make us to feel worse, right? And yeah, I'll then try to clean my cookies. But also I'll do it in separate window because I don't want to disclose some sensitive info there. Maybe those sweet cookies are the actual problem. Cookies. Okay, I just removed those cookies from Chrome. We can try it one more time. No, it still doesn't work. So it's just a browser issue. It's not. We can try, by the way, from Safari also here. You won't see this, but I'll try at least. It's definitely. Oops. Okay, it works on Safari. So that's just the Chrome issue. Let's then Google how we can fix it in Chrome. I've cleaned my cookies, so there's definitely not a cookies issue. Help about delete cookies. Okay, restart the Chrome. Okay, then we need to restart it. Let's restart it. I'll just close it, and then I'll start it again. Okay, it just hangs for some reason. Okay, yeah, I just quit. I'll try to open up a new window. Let me adjust it properly. Okay, yeah, it has fixed. I'm not sure if you're able to see it. Yeah, you can see it. Sorry about that. Let me quickly fix it. Now you should be able to see it. Yeah, you can see that now we have the privacy error, and that's fine. Because if we go to the certificate, why it's not valid? Because it's a staging certificate of the Let's Encrypt. We are doing it against the staging environment first. So that's perfect. It means that our certificate has been issued. So what we do right now, we just set the production environment to the Let's Encrypt, and I was following this tutorial to set up the cert manager. You can see right now. And I go ahead to the very bottom. They have somewhere the production link. Yeah, here we have the production link of the Let's Encrypt, and for you to compare, here is the staging. So the staging link has the staging keyword there, and the production one I pasted here doesn't have it. Alright, I go ahead and our Visual Studio Code and update it, but as far as it's located in secrets, I don't want to disclose some sensitive data, so I'll do it in a separate window. Okay, so we updated everything, and now we updated the string. So what we should do, we need to go ahead and make new deployments. So we fix our certificate, and it makes deployment. I'm going ahead and end this stream right now, and I'll continue with a new stream in, I think, half an hour. So if you still want to participate on that, go ahead and join me in a half an hour. You can subscribe to my YouTube channel and get the notification whenever I go back online. In the meanwhile, I'm leaving you here, and I'll continue on the second stream in 30 minutes. So please join it again. And thanks for watching this first part. I'm looking forward to seeing you in the second part in 30 minutes. Bye bye.